The grid short circuit tests are successful. We've solved another bottleneck in the global renewables industry.
So you mean that renewable energy grids can now run stably despite disturbances, even in extreme cases?
Exactly. Thanks to our key technology, renewable energy grids will become as stable as those with synchronous generators, resilient against power grid faults.
That's really cool. Let's hear from our expert about how we did it. Dr. 𝗕𝗁, Huawei's smart string grid-forming energy storage technology has innovatively solved the stability issue of power grids with a high proportion of renewable energy. How does this technology work?
First of all, we need to understand the main challenges to the stable operation of a power grid with a high proportion of renewable energy. The significant increase in the proportion of renewables has brought problems such as unstable voltage and frequency, wideband oscillation, low inertia, and reduced resilience against disturbances. We are the first to solve these difficulties using algorithms, devices, and chips. For algorithms, the first is the multi-stage voltage amplitude and frequency regulation technology. The grid-forming energy storage devices use the voltage source control algorithm that simulates the characteristics of synchronous generators. When the grid voltage fluctuates, these devices can quickly support the grid voltage and generate a current that is 3 times the rated current within 10 milliseconds, which is close to the voltage support capability of synchronous condensers. The virtual inertia response is started within 5 milliseconds, rapidly restoring frequency stability in the case of a grid fault.
Wow! This is faster than the blink of an eye.
Yes, and we also use the wideband self-stabilizing and stabilizing control technology. Firstly, the wideband impedance reshaping algorithm enables grid-forming energy storage devices to have positive damping characteristics within the wideband range, ensuring stable operation of the energy storage devices. Secondly, our wideband stabilizing control architecture ensures that the grid-forming energy storage system, ESS, can release damping power to proactively suppress the grid oscillation and help stabilize the grid.
Wow! That's outstanding stability!
That's right. For devices, we also have innovative designs. Traditional single-stage power conversion architecture is susceptible to grid fluctuations. Huawei uses 2-stage power conversion architecture and uses a DC to DC converter to decouple the battery voltage from the grid voltage. During high-voltage fault ride-through, the system ensures that no backfeed current flows through the batteries to ensure battery safety. In addition, the system can maintain active power output for better grid stability. Last but not least, we use high-reliability power modules and high-computing power chips to ensure long-term, stable, and reliable operations of devices in complex and harsh environments.
This is totally stable.
The smart string grid-forming ESS is like a synchronous generator, providing strong support for the grid. It stabilizes the voltage and frequency and suppresses various grid fluctuations.
It also enables the stable operation of ultra-large-scale PV plus ESS microgrids, achieving 100% reliable commercial operations.
Stay tuned for our next episode to find out more about cutting-edge energy technologies.